So optimization problems involve finding maximum or minimum values for real-world applications. So for example, like if we had a warehouse manager who wants to maximize the storage of their warehouse, or a farmer wanting to maximize his paddock size. To solve an optimization problem, we must first find a formula for the quantity that we're trying to maximize or minimize, and that is what we're going to focus on in this video, is actually finding that formula before we even think about finding the maximum minimum. We're just talking about finding the formula. So on your screen you can see a question there. A rectangular paddock on a farm is to have a fence with 120 meters perimeter. Show that the area of the paddock is given by this. So before we begin, we need to start writing down some things that we know about a rectangular paddock. So I already know that I can find the perimeter of something. So the perimeter, and I know the perimeter is all the sides added together. So I can have my 2x plus 2y equals 120, because we know that. Now, this is assuming we have a paddock like this, where we have, let's say, y, y, x, x. Okay? So that's where I got those from. Now, the other equation that we have is the area of a rectangle. And we know that the area is given by x, y. You just multiply the two sides together. Now, I'm going to label these as equation 1 and 2, because we're going to be using simultaneous equations, and sometimes it helps to be labeling which equation we're dealing with. So I want to rearrange equation 1 to make it into either an x or a y, so I can do some substitution. So I'm going to rearrange 1. So if I write that down, we have 2x plus 2y equals 120. And we can do some rearranging here. I'm going to make y the subject, but it doesn't really matter which one you do. So I'm going to minus 2x from both sides. I get 2y equals 120, take away 2x, and then I can divide everything by 2. At this point, it's a fairly relatively new equation, so I'm going to label it as 3. So I do have it in terms of y now, so what I can do is actually substitute that. So I can substitute my new equation, so number 3, into our area equation, so number 2. So if I had a equals x, y, the y is now changed into 60 minus x. So all I do is literally replace the y with 60 minus x, and then I can expand the brackets, and I get a equals 60x minus x squared, which is what the question asks us to do. So I just found the answer to that, all right? So it does involve a good amount of algebra skills, simultaneous equations, to find these type of formulas, because you're using multiple equations, and ideally you want one at the end. So here we have another one. We have a travel agency which calculates the expense E per person of organising a holiday in a group of people as E equals 200 plus 400x, and the cost C for each person taking holiday is blah. So it's important here that we go through and we actually identify the important parts. So here's an important part. Here, here, and we need to show that we're getting this. So before we begin, I'm going to write these down. I know I have cost equals 900 minus 100x, and I got expense equaling 200 plus 400x. All right, now we are talking about profit here. So profit, if you don't know, profit is the cost that you make the things minus the expenses. So the cost of the trip. So in this case, we're going to have 900 minus 100x minus 200 plus 400x. All right. So the front bracket stays the same, it doesn't change, but everything inside the second bracket changes signs. So if it was positive, it's now negative, and if it was negative, it's now positive. At this stage, we can collect our like terms, so I'll underline it, and then we get P is going to equal 900 take away 200, so 700, and then we have minus 100x take away 400x, so minus 500x. All right, now this is per person, so this is the profit per person. All right, so if we wanted to find the cost for the group, we need to multiply by X people. So P is going to equal, I'm going to put it in red so it really stands out, X 700 minus 500 X. We can then expand the brackets, so we get profit is going to equal 700x minus 500x squared. And that is the formula. So again, with these type of problems, ideally you're trying to find a formula and an equation that you will then use later to find your maximum and minimum profits, costs, areas, things like that for these optimization problems.